Yeah, hi. Welcome. I will be talking about writing digital exams and securing them with remote attestation and cloud computing. I'm Thore Sommer. I'm from the University of Applied Sciences and Arts, Northwestern Switzerland. A very long word, normally abbreviated to FHNW in German. So a bit about us, because we have probably a different background than most here. We are a multidisciplinary team going from developers, security experts, to normal lecturers in the university, to people that are involved in university development. And what was the goal that we set out to solve? So we wanted to do competency-based digital exams. What does that even mean? So for that, I brought two examples. It means that students want to write about the same thing in their exam that they're normally taught also in class. For example, in life sciences, we do a lot of analysis of images, and during the exam, they also want to do that digitally. So they do that with their computer, and they want to do that also during the exam. Another part is from the School of Education. They do a lot of assessments, so speaking, writing, and they want to do that at their own pace, on their own devices, listening to audio files, recording them, and write about that. So which challenges did we face or did we want to solve? First of all, if we want to move to digital exams, they should be still fair. They should be secure, in the sense as they are secure as an exam written in a lecture hall. They should be easy to use and robust. The worst thing that can happen during an exam is some technical issue and you cannot write your exam. That is a fear that every student and every lecturer has. So that should be solved. And also, we need to enable the platform to do that, and for that we choose that we want to do bring your own device. So that is also an important part to how we wanted to solve that. So how did we do that? We have three components. First of all, we have LearnStick, which is a Linux distribution that provides the lockdown of the device itself. Then we have Keylime, which is a remote attestation project that we secure the LearnStick environment with. And then we have CAMPLA, which is our management interface to write the actual exams on, which is also running the exam in the cloud, but for that we look at that a little bit later. So I said, we want to do bring your own device, but bring your own device in a normal system, the student brings their own device, as it says, and then you install some software on top of that to write the exam. So our trust boundary is between the application and the operating system level, which is kind of difficult because the student still controls the operating system and we cannot secure that layer. So what we call bring your own hardware in that case is that the student just provides the hardware and we use our own operating system, in this case LearnStick, to secure the operating system level. That has also the advantage that the student doesn't need to install any software before the exam, they just need to boot this distribution. But of course, we still don't have any trust established in the hardware, and then here comes in the remote attestation part, where we use a trusted platform module to attest also the hardware and bind our operating system trust also to the hardware itself. So I talked about a TPM here in the room. Does everybody know what a TPM is? Just show of hands, probably. Yeah, it looks good. Just a small refresher. Provides cryptographic functions and also provides us a device identity. And mainly the big part here is that we can have the platform configuration registers where we can chain it to the root of trust of the TPM to secure the operating system that is running on that. So we have now, we now take a look at the cloud assessment management platform, and it's based out of three parts. First of all, we have the backend. So we want to write an exam, so it provides all the interfaces, and so it provisions the VM where the exam is actually written on in the cloud, has the security properties, and provides also some user management and some integrity management of the data. Next, we have the lecture review. so we wanted to make it easy. The lecturers can only create new exams based on templates, so they don't need to know how to configure an entire VM. They can hand in some data where the student can the student can use during the exam, for example, the task or the material that is used during the exam. And then lastly, on the student perspective, we have that they can hand in data, which is important for open book exams. So the student can hand in data beforehand, and then they normally log in to the exam and can write the exam, and afterwards also hand in data. So here, the process is that also the lecturer itself cannot interfere with any of the exam process itself. It can only start, monitor it during the process in the means of is the exam running, and also stopping it. So how does that look in practice? We have our student device. Then we boot from that device. So we have the TPM to ensure that our security, and we boot up, and we have the Linux integrity measurement architecture and secure boot and all that kind of stuff running. And then we connect to the cloud system, and in that system we have now the Keylime component running that is now testing, does the student actually have booted from the right operating system with our security properties, and otherwise also the management system that now provides either like a cloud RDP session, so we run, for example, in Azure Cloud and provision like a new VM for the student there to connect to, or in a very simple case, we can also provision like a web browser session. So if you had e-assessment tests over like an e-learning platform that can run locally for that, you don't need any resources in the cloud. So then the student connects to that and then writes the exam, and afterwards they can hand it in, and that's that. So what are the challenges of actually doing that? First of all, we talked about also today a lot about remote attestation and what data we want to attest. But first of all, collecting the data from the distribution of what data do we want to attest, how do we test it, how do we define a trust opinion, and also defining it in a way where normal users can understand if the system is secure or not. Second, threat modeling is a very, very important thing if we talk about trust, because against what kind of threats do we want to actually protect? In our case, in an exam, in a lecture hall, we want to be as secure as a paper exam. So it's not the magic bullet to solve all your problems for cheating, but it should be as secure as a paper exam if you write that. So that is also important if you communicate to non-technical people what technology can enable you to secure and what not. Then also abstraction and separation. We try to make it as easy as possible for the lecturers and also for the students to use, so that they don't need to care about what is a TPM, what is secure boot, what is the trust decision in the end that's happening, or for the teacher, they want to just write an exam with the right software running and not want to care about what is running actually in the cloud. And lastly, we run on consumer commodity hardware. So we heard a lot about trusted execution environments today, but as of today, the only thing that we have on commodity hardware is integrity measurements with TPMs that are readily available, and also integrating that fully with different hardware manufacturers and seeing that we can run on those. That was a challenge that is solvable, but also very, very hard. But the conclusion is it actually works. We run our CAMPLA system now over 100 exams, not all of them with like TPM technology enabled, but that works, the base platform works easily. Then we now run on 340 different devices, so from different manufacturers, different notebook manufacturers, it generally works, and also from the students and from the teachers. We have a very high acceptance, which is very good because they want to do competency-based digital exams, because it doesn't make an exam easier, but it makes it way better to apply what they learned from the real world also to the exams. So what are the next steps that we want to do? So in Linux, we have mandatory access control systems like SE Linux and AppArmor. We want to fully integrate those also locally. There's a lot of challenges of, for example, prohibiting shells and interpreters for users to run. If anybody tried that of you tried that, please get in touch, because it's a difficult problem to actually solve. Then we want to do more. We want to look into confidential VMs, because currently we run our VM in the cloud and provide some guarantee that the data is with the data integrity from our side of the system. So if the student hands in their data, we sign it, we hash it, and provide the student with a hash where they can validate that their submitted data and the data that the lecturer corrected is like the same. But of course, we can now start leveraging the technology to also provide a more secure running in the cloud, so that we can fully isolate that and provide more guarantees on that. And yeah, the other one is generally local integrity enforcement. There are a lot of mechanisms that can be enabled in Linux, but also that just need to be flipped and have good policies in place so that you don't accidentally lock out a user during the exam. The next step is non-TPM devices. Unfortunately, a TPM is the only root of trust we have in many, many systems. But of course, like, for example, the new M2 Macs are out there, and we want also students to use their devices. And then the challenge is, first of all, how do we support our distribution on that? And second of all, do we have some kind of root of trust? Or can we add some kind of root of trust so that we can extend to that? And also, if you are a university, we are currently collaborating already in Germany and in Switzerland with different universities. But if you're interested in digital exams in this kind of form, just get in touch. And also we had interest from high schools, but a high school doesn't normally have a cloud connection. So we also are working currently with a MSP to provide a SaaS offering so that they can try it out. Yeah, so you can find more about the project on that link. And otherwise, I'm open now for questions. Yeah, probably. Yep.
Sorry, I'm kind of short. So for the exams that were not accepted, what were examples of problems that arised which made them not accepted? Was it related to the remote attestation, or was it like other factors?
In what sense not accepted? So
Can you go back to the slide that with the smiley face?
Yeah.
Yeah, so you mentioned it was a high acceptance rate.
Okay.
So what about the ones that were not accepted?
So it just depends on if it runs on your own hardware. So we also have like a big pool of like replacement devices in that sense. And also it depends if their use case was fully covered, and then, but generally there was not a big, oh no, we don't want to use it. It's more like we provide infrastructure to do exams, and in some cases there was also the expectation that we provide like the pedagogical and didactics track for that, and that we don't do. So there was sometimes then that, but generally the acceptance was not related to the remote attestation part at all. It was just, yeah, implementation.
Okay. Sounds good. Thank you.
So this is actually a really interesting concrete use case for Keylime, which is great to see. I had a question kind of around bridging the gap between, in your diagram, you had Keylime kind of in the learn stick layer, but then it's using the TPM, the hardware from the student. So like how does it kind of use the student's hardware? Are there any like how invasive is that? Are there any privacy issues around that? Are there like certain things the student has to do? Like if you don't have secure boot enabled on your system, for your own reasons? Like, how does that
Okay.
affect the...
Yeah, so we have an onboarding process for devices. So the student brings their device because those kind of exams, we write them not like cold start, the student comes first with their device to the lecture hall, but there's normally an introductory session, and then the devices can be onboarded. For those familiar with TPMs, we chain the identity back to the EK certificate. And of course, there you could argue some privacy concerns, but that is the only one, because we need to have secure boot enabled to make that all work, but if they want, after the exam, they want to disable secure boot and enroll their own keys, they're welcome to do that. But during the exam, we want to have the secure boot chain like normally, and for the TPM, we use it as a device identity for the device to onboard that.
Okay, so the EK certificate from the TPM is the only thing from the student system that's entering this sphere. Okay.
And some the static PCR0 to have like CRTM measurements, because those are otherwise difficult to record. But yeah, the rest is complete. Our goal is to not touch anything on the student's device, which makes their life easier and also our lives, to be fair. Yeah, thanks.
Thank you for that talk. So we'll take about a half an hour break now.